Hi guys, in this video we would be solving a DSA question which was recently asked in Amazon online assessment round. So this is that question. You can pause the video and try to come up with the solution. Okay, I hope you have tried on your own first. Let me explain the question first. See, so we would have an array of integers as the input, okay, and we can perform certain operation on that. The first operation is increment the prefix by 1 from index 0 to index I. So what does this mean? So let's say we are talking about index I, which is over here. So I have to take entire prefix from index 0 to I and increment all the array elements by 1. So this becomes 2, this becomes 3, and this becomes 4. So this is what the first operation is saying. The second operation says that we have to decrement the prefix by 1. So now let's say we are talking about this index. So I have to take entire prefix and reduce all the elements by 1. Right. So these are a couple of operations given to us. And the goal is to return the minimum number of operations to make array elements as 0. So I have to find the minimum number of operations needed to make all the elements 0. This is what I have to find. Right. I hope you understood this question. Talking about the constraint, the size of the array is this. So the maximum size of the array can go up to 10 to the power 5. This is the hint number 1. Right. What is the hint? Hint is we have to solve this question in either big of n or big of n log n. So this is hint number 1. So this question can be solved in big of n log n using segment tree, but I won't be explaining that approach in this video. We would be focusing on this big of n solution because generally in online assessment round we don't have much time. So I think we can't implement segment tree in less time, right? So let's focus on O of n approach. So first point in O of n approach that always comes to my mind is traversal. From where should I travel? Either left to right or right to left. So let's check out that first. So in this, will traverse from right to left. Why? Let me show you. See, when we traverse from left to right, what we'll do is we'll first make this element as 0, then we'll make this element as 0, then we'll make this element as 0, and so on and so forth. So in order to make this element as 0, I have to perform that decrement operation on the entire prefix. So the prefix is this. So I'll perform decrement operation on this prefix and get 0. Right. Right. So after step 1, our new array would look something like this. Understood? Now the next step is make this element as 0. How to make this element as 0? Choose the operation number 2, which is decrement the entire prefix by 1. So we'll choose that operation 2 times. So minus 1 will be minus 2, right? So minus 2. And this should be applied to entire prefix. And hence, after step 1, after step 2, this will become 0, but the first element would become minus 2, right? Because we perform the decrement operation on the entire prefix. I hope you are understanding this thing. So now this element has become 0, but this has become non-zero element. Now in the next step, my goal would be to make this element as 0, which I did. Then I will try to make this element as 0. Then again I will try to make this element as 0. So entirely this particular approach, that is going from left to right, is very tricky or complex, you can say, because operation on a particular element is affecting on element which is already operated, right? So hence this particular left to right traversal is complex. So let's check out the right to left traversal as well. So in the right to left traversal, I'll first make this element as 0, then this, and so on and so forth. Okay. So how to make this element as 0? Just do -3 in the entire prefix. Okay. So -3 plus 3 will become 0, right? Now, from the next step onwards, whatever operation I will perform will not affect on this 0, will not affect this 0, right? Because both the operations are a prefix operation. So they will only affect on the left side. They will not affect the already created 0. And this is the reason why I chose right to left traversal. I hope point number 1, which is right to left traversal, is clear. Now, point number 2. So after every step, that is after performing operations, we have a new array, right? So initially our array was 1, comma 2, comma 3. But after step 1, our array would look something like this: -1, comma -2, comma -1, comma 0, right? This is how our array after step 1 would look like. But we cannot create new array after every step, because if we do that, then the time complexity would be n square. But we have to solve this question in O of n to avoid TLE, right? So we have to make certain observations, particularly 2 observations, in order to avoid creating these arrays, right? And so first observation is, see, we are first making this element as 0, right? How? Just take the same value with the opposite sign. Same value with the opposite sign. So this element will become 0. But the operation says we have to perform on the entire prefix, right? So once I'm making this element as 0 by using -3, this -3 is getting propagated on the left side. This -3 is getting propagated on the left side, right? This is the observation number 1. That whatever I'm taking over here should be propagated on the left side. Okay, this is observation number 1. Second observation. So after step number 1, our array would look something like this, right? After step number 1, our array would look something like this. So since I want to make this element as 0, what I am doing is I am taking the same number with the opposite sign, right? So this will become 0 in the next step. But without creating this array, how to know that at this position -1 would be present after step 1? Without creating this array, how to know that -1 would be present at this step? So observe this thing. This is observation number 2. The original array element plus the propagated value will be the new element. And on this new element, you have to do the operation to get 0. I repeat, original array element plus the propagated value will give you the new array element, right? If you still have any doubt, I think this should clear this doubt, right? So see, after step 2, the array element is -1. After step 2, the array element is -1, and on this -1, we are doing +1 to make 0, right? Now, how are we supposed to know that after step 2, this element would be -1? Again, the same thing. Original array element plus the propagated value 1 plus the propagated value 2 is nothing but 1 minus 3 plus 1 is equals to minus 1, which is nothing but this value, right? So these are the two observations which solves this question. I hope you understood this thing. Let's look the observations once more. So observation number one said that changes on a particular element or changes at a particular index should be propagated on the left side. This was the observation number one. Why are we propagating this element on the left side? Because we have to calculate the new array element at the after step one or after any step. We have to calculate new array element, right? And how to calculate new array element? It is nothing but the original array element plus the propagated value. So this element is nothing but the original element plus the propagated value. I hope you understood this approach. Now let's check out the code. So I have defined the function as minimum operations to make all elements 0, and it takes the integer array. This variable represents the minimum number of operations to make all the elements 0, and this variable represents the total propagated value on the left side. Okay, we are traversing from right to left, and after each step, I mean, before each step, before performing any operation, we are calculating the new array, new element. Okay, we're calculating the new element by using that formula, which is original array element plus the total propagated value will give us the new array element. Okay, and we'll also increment the number of operations. Let me show you what is this operation. So here for this 3 I took minus 3, right, to make this 0. So the total operations we performed are 3 operations. Which are the 3 operations? This. I performed this operation 3 times. Right? I have performed this operation 3 times. That's why I am taking the absolute of this. Absolute of this. Okay. And if the new element is greater than 0, then the propagated value will be negative of the new element. So since the new element is greater than 0, then the propagated value is the negative of new element. If the element is less than 0, then the propagated value will be the absolute of this new element. Just see over here. Propagated value is the absolute of new element if it is less than 0. But if it is greater than 0, it is negative of, it is it has opposite sign. I think yeah, we can also write this as minus of this element, and this becomes we can just get rid of this if else statement then. Now let's execute this code. Let's see what's the answer for this solution for this input. So it is 9, right? And it should be 9. I have solved that over here. So after step 1, I mean, for first we'll try to make this element as 0. So it will take 2 operations. Then we'll make this element as 0. Again, it will take 2 operations, then 3 operations, then 1, and then 1, which will total up to 9. And that's the reason why the answer is 9. And let's run this test case as well. And it is 5. The answer should be 5. You can check out, the answer will be 5. Okay, I hope you understood this approach. And yeah, that's it.